You know, for all of human history, we've only ever seen one side of the moon. But what about its hidden face? Turns out, our closest celestial neighbor has a secret identity, a totally different world concealed from view. Today, we're going to crack the case of the moon's two faces.
Have you ever really thought about it? Why the side of the moon we always see looks so different from the side we don't? I mean, this question puzzled scientists for decades. We look up, we see the man in the moon, right? Those familiar dark, smooth patches. But then spacecraft showed us a completely different world on the other side. So what's going on up there? Why the cosmic split personality?
And I mean, the contrast is just, wow, it's stark. On one hand, you've got the near side, the face that's always looking at us. It's covered in these huge, dark, smooth volcanic plains called Maria. But then you flip it over, and the far side is the total opposite. It's bright, it's rugged, and it is just absolutely pummeled with craters. A classic Janus-faced puzzle for sure.
Okay, so to solve a mystery this big, you need a world-class detective, right? And for this story, our detective is an amazing NASA mission, one that was designed specifically to look deep inside the moon and figure out its secrets. So let's meet our hero, the GRAIL mission.
So GRAIL, which is short for Gravity Recovery and Interior Laboratory, launched back in 2011. And it wasn't just one spacecraft, it was a team of two. And they had these great names, Ebb and Flow. Now their whole job was to fly in this perfect formation around the moon. And by measuring these teeny tiny changes in the distance between them, they could build the most detailed gravity map ever. It's basically like giving the moon a full-body CT scan.
All right, so what did Ebb and Flow find out? Well, their data revealed a whole bunch of crucial clues hidden right there in the moon's gravity. And these were the clues that were finally going to help us put all the pieces together.
Okay, first things first, we got to understand the scene of the crime. The moon is tidally locked with Earth. All that really means is that it spins on its axis at the exact same speed that it orbits around us. The result? One side is always facing us. And that's the whole reason the far side was such a huge mystery for so long.
And here's the first big clue from GRAIL. That same gravity that keeps the moon in place, well, it's also constantly squeezing and stretching it, kind of like you're squishing a stress ball over and over. This flexing, which scientists call tidal deformation, creates a ton of heat inside. GRAIL's instruments were so incredibly sensitive, they could actually measure these tiny monthly changes in the moon's gravity from all that pulling. It was proof that Earth's gravity is literally reshaping the moon.
So all that squeezing and stretching generated a ton of heat. But here's the kicker. It wasn't even. The side facing us, the near side, got way warmer. We're talking 100 to 200 degrees Celsius hotter. That is a massive temperature difference, and it turns out to be a super critical piece of the puzzle.
Okay, clue number 2. We've got a hot side and a cold side. GRAIL also confirmed something else. The far side's crust is a lot thicker. You can really think of it like a thick, protective shield. And that shield, as we're about to see, played a huge role in how the far side developed, or maybe how it didn't develop. All right, let's recap the evidence. We've got a tidally locked moon, a warm near side, and a thick, cold crust on the far side. So, how does it all connect? It's time to connect the dots and solve this thing.
And boom, here it is, the whole solution in one go. Earth's gravity created this huge imbalance. The near side got warmer and softer, which made it perfect for volcanoes to pop up. Meanwhile, the far side stayed cold and hard, basically preserving its ancient, cratered face for billions of years.
This really is the aha moment. So, step 1. Because the near side was always being tugged on by Earth, it stayed warmer and squishier. Step 2. All that heat created a partially molten layer of rock deep down. Step 3. Eventually, all that magma had to go somewhere. It erupted, flowed all over the surface, filled in the old craters, and created those dark, smooth lava plains we call the Maria. But on the far side, that cold, thick crust acted like a giant lid on a pot, just blocking any magma from getting out. And that's why its ancient craters are still there, perfectly preserved. Case closed.
So, there you have it. We've solved the mystery of the moon's two faces. But, why is this so important? What's the bigger picture?
Well, the impact of the GRAIL mission was just huge. I mean, it didn't just solve this one big mystery. It completely changed how we think about the moon. We learned its crust is way more porous and actually thinner than we believed. It found these features called dikes that suggest the moon might have expanded a tiny bit early on. And all of this incredible data is absolutely vital for planning the next generation of lunar missions, for both robots and humans.
And that brings us to one last really cool thought. The moon is basically a time capsule. It doesn't have an atmosphere or much geology going on, so its surface has preserved this incredible record of the early solar system, a record that's been totally wiped clean here on Earth. So, if solving this one mystery taught us so much about the moon's own crazy past, just imagine what other secrets it's holding about the early, chaotic history of our own planet.